138 review session. I'm Garrett. I threw my email address up there, so if after the session you have any questions, you can shoot me an email, and I'll try my best to answer them. It's hard for me to answer specific math questions via email, but I'll do my best. Here's a bit of our agenda. I'll tell you about myself. I'll tell you about GradeUp, the organization that this is all through. Some of you have the little cards that hopefully make it all the way around. Then we'll go into topics, and we'll end with questions and answers. Do you want to talk about GradeUp, or should I just start going?
Why not? So hi guys, thanks so much for coming out today. Hopefully you get some really good knowledge. Garrett's one of the most experienced tutors we have at GradeUp, so I'm glad that he's able to meet here and help you guys out. So GradeUp, we're basically a one-on-one premium tutoring service. So started a couple years ago, primarily based in Woodford Laurier University. We've grown to a couple other campuses. We've done over 1,000 hours of tutoring at this point in various campuses such as Ryerson, U of T. We're also at UW, and we do offer several UW courses such as Math 138, Math 135, various math courses, and others. So I hope, as Garrett mentioned, we do have cards going around. If you haven't gotten one, just know our website is very simple, gradeup.ca, www.gradeup.ca. And you can go up there, book a tutor. It's very simple. Our packages and everything are online. But for now, Garrett's going to go over the entire Math 138 course and just do a quick review with you. We're very excited to partner with the Double Degree Club to be able to do this, and hopefully we can do this for the semesters to come. So thanks very much for coming out, and hope you enjoy the session.
Okay, so about me. I am a fourth year double degree student. I'm majoring in combinatorics arts and optimization at UW, and I do international business at Laurier. So yeah, if you guys have any questions about that, I can answer. I do tutoring. I've been tutoring all levels of math for about 7 years. I've been with GradeUp for the past 3 years. Before that, I tutored at Kumon. I don't know if any of you know that. Good times. I am a tutor at UW, so I do 138, 137. I think I do both the lineages and I do all the math for sciences. But I'm leaving after Tuesday, so you can't book sessions with me. We do have other tutors who are not as great as me, but also not bad. So yeah, that's a bit about me. Nothing interesting. So we'll get into the topics. Start with integration by parts. I personally enjoy doing integration. Might be a bit of an anomaly. You're all double degree students, right? Is that everybody?
Yep.
Sure, laugh. It's a little weird. Are you all math or are you CS as well? Yeah. CS as well. Okay, so you don't necessarily have to do Calc 3. So yeah. Oh no, Calc 3 is awesome. Calc 2 is the hardest calc. I'll give you that. Math 138 is the most challenging calculus. You can all write that down. So yeah. Anyway, integration by parts. Basically, you have some complicated integral that you want to split up to make it more simple. And you can do so using this formula here, which you hopefully all know because this was like the first topic you did. I just need a couple common functions that will be u and x. U of x will almost always be a polynomial because it's easily integrated. You can just add one to your exponent and divide. Ln x, you cannot integrate, so you want to split that. You want that to be u. And then v of x is any exponentials and trig functions. So I figured I can only do so much just talking to you about math, so I gave you a couple examples to work through. I'll give you not too long to do these, but if you want to give them a shot, we'll just start with the first one. If you guys got one, you can probably do the second one as well. But I'll give you a minute on that. Yeah, I think it's not easier to be honest. Let's see if I write over here. All of you can see. Spoiler for everyone. People just about wrapping up. Want me to start going through an answer? Want to keep working? No one has any feelings? Well, that guy says he's good, so we're going to keep going. What's you? Nobody knows. Science, yes. I'm not going to test you on that. Hopefully know how to do basic conversion. And that leaves dv to be e to the x. E to the x. So you get uv dx, that's right, dx sin x minus dx cosine x dx. What did I do? Okay. I also make mistakes, so if I do make something on the board here that's wrong, please let me know. Everyone's okay with this though. Sorry, my handwriting is kind of atrocious. I will not block you. Do it again, because we still don't know that, so we're gonna do it again. That's you. You. You negative sign. I also forgot all my plus C's. Don't forget those. Still good marks. Integral e to sin x. Pull the negative out, be this plus. Everyone's okay with that. Do I need to keep going, or does everyone see how this one's going to end? We get it. That guy gets it. So we're going to say we're all good. Just as a summary, this you would obviously this is just going to keep going, but this term matches what we started with. So you would add it over to the other side and divide by 2, and you would get your answer, which ends up being e to the x times sin x minus cosine x over 2. Let's see. Let's see, yeah, you'll lose them. Does anyone care about ln x? Yeah, you care? Yeah. You want me to do it? It's x ln x minus x. Let's see. You want to see that one? Okay.
Sorry for those.
So the only challenge with this one is that there's not 2 obvious terms here. So what's u? What's dv? Maybe dx. Somebody up here said it. But so that ends up being your dv, and then v is x. And this is. So if I were to do this, I would get x ln x minus integral x 1 over x dx. Does that make sense? Comes 1, which is an x. Let's see. Everyone tight with that? me to go through that a little more slowly. Okay. So that's basically integration by parts. Not that challenging. Don't forget your plus C's. Yeah, any further questions on integration by parts? I'll give you a chance to ask more questions at the end, but if you have any super pressing issues at the moment. Nope, cool. Okay, trig substitution, you really just gotta memorize these formulas. Like if you memorize all this is on my little handout, so you don't have to write it all down. Memorizing these formulas is pretty key. It'll really help because that's all there is to this, is these formulas. So we can go to the next slide. That first one is really hard, so we're not gonna bother with it. At least I don't want to do it. The second one though is more in line of what you'll actually see on an exam type situation. So I'll let you guys struggle through that for a bit. Most of these examples, yes, because they can. I can only talk about it so much. Yeah, well, no one's speaking. These are also fairly simple, like these are not hard concepts. You can kill them. Yeah. Yeah. Which slides do I have? Like 28 or something. Like you can take. Yeah. I'll just cut them off. Just to the formulas you go on. Haven't written down the problem yet. Nice slow.
There is a handout that we created that Tyler has access to. I believe he posted in your group, or will give you access to it soon since it's not printed out yet. So you'll be getting a chance to look at that.
You're a good man, Tyler.
And please feel free to ask any questions. This is your chance to do so.
Yeah, I can answer questions too. Not limited by what's on the slides. Did you see the problem? Did you see the problem?
Yeah.
You fine? Yeah, I think I want my next one. What's my substitution going to be? We're not doing simple substitution, we're doing trig substitution. Sure. Okay. So that leaves me with, I guess I should want to just do x equals sine theta. Makes my life a little easier. Dx equals cosine theta. So just plugging those in. Sine theta. 4 theta. Cosine theta. Okay, everyone's happy with that? Resounding answers. Okay, so this doesn't change. What happens to our radical here? Somebody sounds like beta.
Be loud, just so that everybody can hear.
This is what he said. I agree. Okay? Sorry, I'm trying not to block you people, but I'm right-handed. Sine theta. This is cos squared theta. What's that with that? Right? Everyone's happy still? Yes. Okay. Should I continue, or are you all happy with this? He's happy. This would be a simple u substitution. U equals cosine theta. Okay? You guys gotta answer my questions. It's very challenging for you to know how you're doing. Okay, well, whatever. We're moving on then. Any questions about those trig substitutions? Yeah.
How is 1 minus sine 4 theta really close?
Proceed.
I agree.
This guy agrees.
I just did. So I want
Okay. One. It's not one, right? I made a mistake, guys. I apologize. Okay, so walk me through what I have to do then. I made a mistake.
Well, instead of sine, I could just when you is named x is root with sine theta.
Yeah, so x squared equals sine theta.
Yeah.
Okay, dx equals.
The answer should be x equals. Yeah, 1. Yeah. 1 over 2 root sine theta.
Yeah. So over 2 root sine theta. Okay. Squared. And this changes to some disaster. There's 2 root. Yeah, it all cancels out. Okay. So these cancel out. This is gone. This is gone. Okay, I apologize for that. There's some mistake on my part. We'll go through. Thank you for pointing that out. Okay, moving on. Oh, does anyone have questions about trig substitution now that it's correct? Yes.
Like, how did you go to use the substitution x equals root instead of like?
Oh, because this is So I could write this. I'm just going to rewrite this radical. It's going to be 1 minus x squared squared. So when you're usually doing these treats, can you go back to the one with my formulas? Yeah. So you have a minus x squared. This is your x. This is your x squared. It just happens to be x squared. So this would have been x squared equals sine theta, but I want it to just be x, otherwise this becomes some nightmare that I have to then do work to solve. Okay, any more questions? That makes sense? You all set with that? Okay, moving on. Okay, partial fractions. This is one of my favorite ones to do. You actually, so partial fractions is basically these 3 steps. You just have to factor the denominator as much as you can. So that you can plainly see what each different denominator is going to be. If your numerator has a higher power than your denominator, you want to divide. You want to get it into a polynomial plus some radical, because once you divide, it'll be those first 2 terms will be quite easy to deal with. They'll probably just be x or x squared, things like that. Then you're going to split the fractions up into a couple different fractions based on what the different terms of your denominator are. So that way you will likely end up with just like some constant over the denominator, which is much easier for everyone to deal with. So I got examples. Not yet, no. Nope. I don't know if you know names. Sorry.
Like when you put the numbers in to make it 0.
Oh, yes. You can do that if you want. Let me
Yeah. Oh, true. Oh, shit. You divide it like we went to grade 4. Divide it by 2.
Learning about math.
Yeah.
Oh, yeah. I'll beat it.
Yeah, that's what it is.
Yeah. I guess I just got screwed. Running answer.
Oh, yeah.
Yeah. When you guys do it, leave my mouth with money.
Yeah.
Thank you.
Go again.
Well, scammer right here. But you can send it tomorrow, but I'll skip it.
Yeah. Well, we can do something. Probably.
Yeah, I mean, I'll be back.
Oh, okay.
Everyone just go on this? I would first. Unless we're like super eager about it, we're gonna just do the first one. You want to do the second one instead? But okay. Okay. We had a request to do the second one instead, so we're going to do that. I don't have solutions, so we're going to be kind of working through it. To the floor. 3x squared plus 1. 5x cubed.
Yeah.
Yeah. Currently working through that? Okay. So we're going to factor we're actually going to factor both numerator and denominator. Does anyone have that? Or should I do it out? Do you want to do it out? Okay. I don't know what you got, like, to factor this. Is this the factor theorem you were talking about?
Nope.
Nope. Okay. This is synthetic division. I learned this in high school
Oh, okay.
to divide polynomials.
Is that your divide side?
Huh? No, I'm going to put, this is what I'm testing. Like, so there's certain terms you get to, so I'm testing in this case, I'm looking at the term, like that numerator divided by x minus 1. So I'm testing this as a possible root. The only possible roots are determined based on what this coefficient is and what this coefficient is. The fact that they're both 1 means that your possible roots are 1 and -1. I can actually see right now that it isn't going to work. This cannot be factored. Right, but I'll show you anyway. Has anyone seen this before?
Yeah.
A couple people? I don't think you haven't, when that. They usually don't teach this. I don't know why. Okay. So these are the, I'll just, put it on these are the coefficients of each chart. So 1, there's no x cubed, so 0, 3, no x, 1. So you start with this. That 1 comes straight down. Will always be there. 1 times 1, 1. 0 minus 1, -1, and you keep going through like that. So if I were to, if this last term is 0, you know that this number that you chose is a root. In this case, it didn't work because that is not 0. But what this has done, so I've taken that top polynomial, divided by x minus 1, and I've been left with, I would be left with x to the 3rd minus x squared plus 4x minus 4x minus 4 plus 5 over x minus 1. So that's how that works. the outside of this map factor. -1 is my other option, and it also doesn't work. Does it work? Is this no, it doesn't. Somebody else does something. Okay. Doesn't work? No, sure. Good point. Okay, so. Okay, denominator also has a factor. So it must. With a factor to that. I can take out x. That is one. Pretty sure this is 9x squared plus 5.
Yeah, it's supposed to be plus the. This plus the remainder. I mean, you're adding the remainder, allowing the remainder to go on top.
Okay. So this is as factored as that gets, which is a shame. But we'll make it work. So x is 4 plus 3, x plus 1 over this mess. Everyone's happy with that? As happy as you can be. This. Okay. Does anyone do people want me to keep going? No, that guy does. You want me to keep going?
I'm just wondering, you say x cubed plus cx squared plus dx plus e, or you can't see it.
Oh, sorry, yeah. Oh, well, my handwriting is small. Yeah, that says bx cubed plus cx squared plus dx plus e. Sorry, that is I just wanted to know what my numerator was there. Alright, yeah, so this one ends up being really long and complicated. That's why I didn't want to do it, but there was a request. So everyone could go on from here. Soldier through. Yes. That's far. Yes, yes, that's very fair to assume.
I'm kind of skeptical. Why doesn't it happen? I'm kind of skeptical, right? You would assume that factors into the board?
Yeah. So he asked if it was fair to assume that this would not show up on an exam. I'd say yes, it's very fair to assume. If you track it down. It won't show up. You would get something more along the lines of what my first example was, which I hope everyone saw. Yeah. So he asked if there is if you'd ever see anything your question was you'll always see examples where it can be integrated. Yeah. I mean, there are things that can't be integrated, and you won't see them because there's no point in running on there just messing up. So do people want to go through that first? Yeah, do the first one. Oh, I'll just give you what I got. Did everyone solve the first one? No? Do you want me to go through all the steps? Well, yeah. Okay. Well, okay. So that one was fun. While my computer resumes its time, I'll walk you through the first one, which can be solved in as much nicer. Well, I put it on there. Do you want to? Well, I have the example. Oh, yeah. Yeah, I have my class over here. All right. So the first example.
X squared minus 6. Yeah, this is what it is.
Okay, perfect. Okay, so first step, we're going to do long division. This one you cannot do by synthetic division because it's a multi-term denominator. If it were just like x minus 6, you could do that synthetic division that I just showed you that didn't work. But, so, long division. People in the back, let me know if my handwriting is too messy or too small for you to read. Is it okay right now? That guy gave me a thumbs up. Okay. So, what's the first term? X. X squared minus.
So, yeah.
You would subtract. What's that mean? Okay. Everyone followed my long division, right? Sorry, I sort of wrote through it. It's not overly challenging. Does anyone have questions about it before I keep going? No. People over here, let me know if you're raising your hands, and then I'll lift this one. Oh, just so everyone knows, the reason I did long division, this numerator, the power of this, is greater than the power of that. So I knew that there would be a term outside of it, which makes things a lot easier for me. Okay? I'm going to do some side work down here. Everyone's happy? Okay. Minus 3b equals 3x minus 4. It's still happy. Is everyone okay with this? I assume everyone can solve systems of linear equations. Is that what everyone got? Yes. Sorry.
Yeah. Help me out like that, though.
Yeah, there are seats for those people.
There's another one.
Sure, yeah. You get to answer questions. You're the only people I listen to.
No, what did you say?
What did you say? Do you know who I am? Do you know who I am? Is this on video? Yo, Adrian. No, it's okay.
Do an Oscar speech. Do a contest.
All of you was learning math for 30 years. There's too much to learn. Is it long?
All right. Let's end up this. So these are like, this is the solution. Is everyone okay with that?
Yeah.
Sorry, I just sort of like, I sort of went through it because everyone was talking. Does anyone have any questions with how this all went? Anyone? No. Okay. No, it's fine. We're gonna move on. Okay. So you're gonna see some improper integrals on your exam, undoubtedly. It's integration where one of the limits is undefined for the function, or it's infinity. Oh, sorry. Yes.
Do you have an estimate of how much of the exam is going to be on intervals? Because that's what really depends on 1/3.
No, 1/3 is before the midterm.
Yeah. Anyone can see this in series, right? You're going to see one Taylor series question. There will be one, maybe two if you're really lucky. I only had one on my exam. I had a McLaurin series that I got it wrong. Other than that, you're going to see a bunch of Taylor series. Sorry, not Taylor. You're going to see a bunch of power series, find the sum, interval of convergence, radius. Yeah, oh yeah, I love those. Yeah, guaranteed that's on there.
But we have so many.
You'll have one. At least one. Okay, anyway, improper integrals. Not as fun as the volume questions, but also fun. These are actually fairly easy. You're going to evaluate it as a regular integral and then take a limit. It's not particularly challenging. We can go to the next slide here. People want to go through these? They're pretty easy. Do you want to go through? Or do you have a question? Anyone, the guy behind you.
I'm okay.
You're okay? Are you sure? Well, yeah.
I was just wondering, like, if one of the bounds is infinity, then obviously you treat it as an improper integral. But if there's an asymptote, like that first one in the middle,
Yeah.
but how do you would you just approach all of your integration questions thinking that they could be improper, or does it normally say?
Well, it wouldn't tell. Oh, so his question was, do you treat like, so if you look at this first one here, right? It doesn't go to infinity. Obviously, if it goes to infinity, you know that it's improper. But for the first one, for example, you approach an asymptote. So he asked if you had to like approach each question as if it might be improper, or if you could, or if it'll tell you that it's going to be improper. Sort of the general way to go about it. You know, don't assume every single one is improper, because a lot of them won't be. You should just recognize which functions are going to be, like, if you had 1 over x, that's going to approach it. It has the asymptote of 0. Any of these cosecant like type things. So that's something you do have to watch out for on the exam, is the ones where you have your bound is, one of your bounds is going to be an asymptote. It's not a clearly defined function. Yes, does that answer your question? Yeah. Sort of. It's sort of, you should just know, like certain functions have asymptotes, some don't, some do. It's like this one. Does anyone know what the asymptote is in this function? Cosecant? Yeah, pi is the asymptote in this one. And just n pi. This one, you're going to approach 2. Your, 3, no. It's weird. But, this one, you're going to have 2 asymptotes that you got to consider. And then you just set one of your, so like the first one, you would set pi equal to b, the limit as b approaches pi, and evaluate as you normally would. Any questions? Sorry, I didn't really go through this very much, but.
Can you just do like the first one?
The first one? Sure. I feel like I need someone to speak on behalf of the room, because I don't know what you don't know. Okay. cosecant x dx. And what do I do? Pi over 2 to pi? Okay. It's going to be 2. Yeah, next to that. Right. Anyone know that? Named all that? Did you guys do the integrals of these? You know what it is. Do you know what it is? I'm gonna go with I'm gonna go with nobody knows what it is. Okay. Somebody said. There's also a limit. Yeah. Are you happy with this? Then it's just evaluate this function without limit.
Yeah, it's minus cotangent. It's minus cotangent.
Is everyone's okay with this? You're not.
It's minus cotangent.
Yes, it is.
Oh, yo, cuz. I googled it.
I have lines written down here. I didn't write it up there.
What?
Okay, so everyone's okay with this? Like, it's just evaluating limit at this point, which hopefully you don't do, because that was kind of one.
But does the hopefully expression just
Yeah.
it's a surprise?
That one does diverge. That one just goes to infinity. This goes to can't go to infinity at pi. But yeah. Is your camera still?
Yeah, we're still doing it.
Okay. All right. Areas and volumes. Gentlemen over here are very excited about those. So I draw the pictures. It might not help you. I personally like to see it. It's easier to visualize when you're making your cylinders or discs or washers or whatever you're doing. You can always specify the function in terms of x equals f of y. So instead of having your function being y equals whatever, set it as x equals. Sometimes it makes it easier. I didn't have a specific example for where that happens, but you might just find that it's easier. Certain functions will be easier if you do it that way. So yeah, do you have a problem? Like, if you have any questions, do you have a problem with these? Do you have any questions about these before I move on to just an example? No questions. Do you have one?
How do you go about analyzing questions that are not about the axis?
Oh, that's my example. His question was, how do you go about a question that is not rotated about the axis? So generally, that's why I draw the picture. Like, you can usually, you'll see. One second, like my next example actually does that, so I'll show you on the next one. So you just hold on. Any other questions before I move on to the example that I have? No. Okay. So here's your example. You guys keep working. Yes, I am.
Is this a problem solving workshop or a tutorial or
It's a review session.
review session? You may not welcome this, but I'm just going to put it out there. There is a volunteer appreciation event taking place over at the University Club. If anyone would like to join us, it's a buffet dinner. Free food. You're welcome to get here now if you're interested. I know this is very important, but I just thought I would throw some free food.
You bring the whole thing here?
Okay. Well, while we're all excited about free food now. So I'm not an artist, just so everyone can see. So I drew the picture. It's terrible because I can't draw. But so okay. So this is the curve. This is 4x minus x squared. Right? This is y equals 3. So the two curves that I had to deal with. So the area bounded in here was this. So all I did to draw it, I found the intercepts and I found where it crossed where these two functions are equal, which was at 1 and 3. Yes. So then I drew in dotted line the x equals 1 because that was the axis I was rotating around instead of the x-axis, much earlier. And I just mirrored it over that line because that was all I was doing. So I had GradeUp. So does that make sense up to that point? Disaster. So the best way to go about this one is by cylindrical shells. So what's your radius? I don't know. Does anyone know what the radius would be in this instance? X minus 1. So the radius is x minus 1 because if you look at this, like if I look at 2, I just consider this point here. The radius at this point is the distance between the line of 1 and whatever point I'm at. So 2 in this case. You happy with that? Makes sense? Yeah, if I want to look at this instead. It'd be negative x plus 1, but yeah. I don't know why you would. Oh. So it's always just going to be like, so you mean like before you had, so rotating around this instead. So then it would be this number minus x. So if I had rotated about 3 instead, it would have been 3 minus x. Just think about whatever is farthest right minus farthest left. So in this case, farthest right was x, farthest left was this boundary that we put up, this 1. So x minus 1 is the radius. What's the height? Anyway, height. Yes. Not quite. Or x minus x squared minus 3. Sorry to keep me upset there. Does that make sense though? So because I only care about this area here, bounded between these 2 lines, so it's minus 3, so I'm not considering all of this. Yeah, fair enough. Okay, so then to find this, take the integral. We're going from 1 to 3. Those are the 2 bounds. This is where these 2 functions crossed. Was 1 and 3, that's where they're equal. So that's our bound of pi r h. I'm missing the coefficient for cylindrical shells. So then it's very simple. You would just multiply out, take the integral, write units squared at the end. Is that okay? Anyone have any questions about this? Alright, so I'll repeat the question. I was asked how to do it the other way, because on the midterm you were asked to solve this both ways, and I guess show they would fit. So what are these guys? Cylindrical shells. So instead you want to do these, right? You want to do the washers. Right? That was my alternative. So this one would be really hard to do by washers. Because in this case I would have to solve for what these 2 bounds are. Which is tough. But you could, so you get your weird thing here. But I want like the area of this specific washer. So I would be integrating from y equals 3 to whatever this point is. I don't know what it is. I'm going to call it 5. So then you'd have to solve this function for y. You have to get x equals some function of y, which is really tough at that. But that's how you do it. That makes sense? Sorry, I couldn't go into more detail because that's a quadratic formula. Yes? What? The radius in this? Well, again, I don't. I have to evaluate. I have to solve this for y. And that's hard to do. But it would be, I would get 2 separate functions. I would end up with this and this, like 2 separate things. So it would be this minus this. It's 2 functions, like, I don't know what they are. Actually, they just be negatives of each other, so it would be 2 times this, some square root mess. But then you have to, because it's washers, you have to subtract out this middle thing, which is going to be the distance from my radius, like my axis of rotation, to this curve. That makes sense? Any other questions while we're waiting for you to come back? Well, I didn't do the whole thing, but I showed how you could have done it both ways. Maybe I could have like a midterm. You could have done it both ways. So I used cylindrical shells, you could have done it with using the washers.
There's constantly.
Yeah, so what if it's whatever this comes out to be?
Dude, I have two rap guys. They're my henchmen.
I went down there
Straight from Starbucks.
Like,
Don't
it's
worry.
gonna be
Just watch your back.
this function minus this function.
Who end will you?
It's a square function, so it's gonna be below. Did you mean like it was here? Well, then I would.
He didn't know you were here. It's okay. Oh, you're so funny.
So if I rotate it around this line instead. So my radius is going to be, this would have been 4, for example. It would have been 4 minus x. Oh, for the shells, for the discs. My radius is going to be this. Yeah. It's going to be that minus that. I always try. It just makes it easier for me to see. You don't have to bring visualizing them or chart graphs. But it is much easier if you can actually draw it out and see. Does that make sense how I did all that? Any more questions? Okay. So differential equations. Is this on your midterm or am I into final topics yet? Still on your midterm. Okay. Differential equations is just an equation that contains an unknown function or one more derivatives. The main thing you'll get from this is slope fields and additional value problems. You will likely not see a slope field on your final. They're tedious and not that interesting. But everyone can do them, I assume. You just sort of evaluate a bunch of values. Everyone's okay with slope fields? Initial value problem, you almost definitely will see. It'll give you a differential equation, you'll have to find, it'll do the initial value problem. So I have a really long word problem for you.
We don't have mixing problem.
Huh? No mixing problems. Well, that's a bummer. Okay. I don't have an example of that. I'll find one for you though. And I'll do it later. Let's move on then. No mixing problems. Okay. Sequences and series. I'll move on. I'll give you. I'll find an example for you later. I'll grab something in the textbook that I'll steal. I'll find an example of populations. Huh? This is on the final. Yes. I guarantee sequences and series is on the final.
We've moved past the midterm stuff. That's
Oh, okay. Yeah. So, sequences and series are annoying. I should just sort of what kind of combinations. So I've listed out a bunch of the tests. I think the only one I missed is the limit comparison test. I have one on the next slide, but I do detail them in the little handout I provided. It gives you, what did I give you? I gave you when to use which test, what each test was, and how to determine if it converges based on these. Yes.
Where do we get this handout?
I believe it was
Tyler,
posted on the
Tyler
page.
Okay.
If not, email me and I'll send it to you. Yes.
So a lot of these tests only tells you if it converges or diverges, right? It doesn't tell you something.
It will almost never tell you something. It'll just tell you if it does.
Will they ask us questions where we have to find this out?
Yeah, it'll say determine if it converges, and if so, lines this and finds them. Yeah, so these just sort of learn the tests. Obviously, you have to know every test because they'll work in various different situations. They won't tell you specifically. You won't get a question that's like, use the limit comparison test to show this. It'll say, show that it's convergent or divergent. They won't tell you specifically which test, so you have to know all of them and when to use them. So those are 2 of them. I got 2 more on the next slide. Actually, maybe I'll pull up my handout for you and you can see. I got a nice little table for you. So that's the table I gave you guys. This sort of tells you when it like how to tell if it converges. The only one that I probably could have had more information is this one, because you can also tell if it converges. It tells you more. One of them tells you more. I can't remember which one. And then beneath here, I have a bunch of steps for how to decide which test. Don't memorize like all of this, that's a lot of words. But it is useful to look over. There are certain cases where one test will work better than another. Like, don't use certain tests if you don't have the right circumstances for it. So yeah, this handout has been posted already, I think. If you're not in that group, shoot me an email. I'll give my email again at the end, and I'll just tell you. I'll send it along to you. I could make it better too. It's not the greatest handout in the world. Okay, where the hell is it? Lost my cursor. There it is. So, why? All right, so yeah, so the ratio of root tests tell you more: divergent, converge, or diverge. You don't know, and absolute convergence. So that's one that's sort of must have. Do you have questions about these right now? Since this is the first topic on your exam, any super pressing issues? No. Okay, so I didn't really do any specific examples of this because it's just blindly plugging and checking through formulas. I don't need to do those. You can do those as well as I can on your power series. This is one where you'll see these where it'll tell you to find the radius of convergence and the interval of convergence. Yeah. So it's just, all you have to do is try to find where it, all the number r such that the series is convergent with that which converges. Yeah, so you gotta solve for these. You'll have questions like this on your exam. Almost guaranteed. I can guarantee it's pretty So I do have a couple examples of these for you. These are that don't have solutions for, so I'm going to need your earlier I was like, oh damn, they can't do that. I planned on telling you, but then I was dying at first.
Oh, you can't do that? Why can't we do it? Yeah.
That one.
Why can't we do it?
No, you don't have any terms. This is just going to be a big long thing. Also, even if you could, it would diverge because next to the end.
So infinity.
You just have increase, massive exponents, massive coefficients, times x to a massive coefficient. You have infinity squared, x to the infinity. You'd have to know what x is. I realized that when I was looking at it earlier before coming here. Oh, damn, you can't do this. Has everyone done the first one, though? Ratio test? Yeah. You know why? Because the factorial guys. Okay. All right, so you know the ratio test. What we're going to do here.
Huh? What? Dude, I tell you, no one's gonna fail unless they legit did the jack. they passed me for like my resume. It was the shittiest
Okay.
resume.
So somebody tell me what I'm going to do first. I don't have a solution. Are you ready? Okay. Apply it.
Go ahead.
I'm going to take the lead.
Actual value.
That's all you got. Let's get started. Yeah. You want brackets? Okay. Cool. Yeah, but it's
Wait, did you know?
They like give you shit.
it's not factorial. I don't know if people said factorial, but factorial is not. All right. So next. Yeah.
Equal to 0, so which is less than 1 for all x. So by a ratio test, it converges for all real numbers.
Yep.
And then the interval is negative infinity to infinity.
Okay. Does everyone understand what we did here? So just to walk through, because I had these people in the front telling me what to do. This is the ratio test. The ratio test is used to prove what the convergence was. We just sort of took an plus 1 over an, took the ratio with the limit as n approaches infinity, and it came out to 0. This means that it converges because it's less than 1, and it converges for all values of x. Does that make sense? This is all detailed on my little handout that theoretically all happens. And sorry about that second one, actually can't be solved. And I apologize for that. Moving on. Okay. So, well, first, that one, last one makes sense. Everyone's okay with that. Basic stuff. I'm going to skip Taylor series for now. No, these are long, and I want to make sure I get through parametric as well. No, we will. Don't worry. We'll go back to Taylor series. I know we're all very interested in this. But that's what we're going to wrap up on, so we can spend the most time on it. Parametric equations. This is the last thing you guys did. How much did you guys get? Did you guys do polar coordinates?
No.
Good. I didn't include that.
Yo, Max is scared, man.
Conics? You didn't touch on conics. Okay.
I know.
You did, okay, so conic is hyperbolas, hyperbola, parabola, circles,
I never
ellipses.
said that.
Oh,
I get zeros.
We only did
Even more annoying than
What'd you do? Okay.
Why do you feel peachy?
Parametric equations. So you're going to have to graph a parametric equation. The most important thing with this is to make sure you show the direction that you're traveling, because the parametric equation, x and y are both changing with respect to t. So as t increases, you're going to go in little circles and fun things like that. So you're going to just sketch them almost the exact same way as always. You go find derivatives, find what the slope is, find the intercepts. And yeah, that's about all you have to do for those. I got an example for you. How about finding intercepts? You don't say it? Nope. Y equals t squared. Okay. Intercepts, what are they? Well, how do I find them? I don't want to. You said you knew.
I live on the edge.
Somebody must know. How to find intercepts here. Alright. X equals 0. It means that okay, so x equals 0 and b equals 0. Root 3. Oh. You don't really consider negative root 3. You can't have negative time. Do you guys deal with negative time? Yeah. Well, good. You can have negative time. It's plus minus. T is time because in a parametric equation, like you'll get something that looks like this, and like this is t equals 0. Then it's sort of parametric equations are used to model like a particle as it moves. So at t equals 1, and it's here. Which is not necessarily. Particle doesn't need to return to 0. This is not necessarily the graph that we just drew. This is just a graph. But that's what, so this is t equals 0. This is where it starts. This is t equals 1. So it's moving along this line, which is why I said you can't have negative time, but I guess in your classes, if you consider it, then we'll look at it. Anyway, so these are the values where x equals 0. So we know, so then we can plug this t value into this equation and find out what y is. So you find the y-intercepts this way. So at 0, it's 0. And 3. Okay. So same deal with the y-intercept, or sorry, the x-intercept. That sounds interesting because it's just going to be 0. Everyone sees how that happened. So I have the intercepts. What am I doing next? Somebody tell me.
So you don't drop it a negative root 3.
Negative root 3 squared is 3.
Oh, okay.
Sorry.
Harvard?
Okay, what am I doing next? You guys gotta tell me if you want to get to Taylor series. I'll spend all day staring at this graph. These 2 points are.
I don't know. I just use a chart for like T0, 1, 2, 3.
Yeah, that's fairly decent. Well, we'll do what he said because this will give you. Can't do charts. Why not? That is true. Which is why you'll take the derivative. But this does give you the points, specific points as you're moving along. But they're right. You have to know what the graph is doing in between. Because you might find out that your x value is up here, but you don't know if it's doing this in the meantime. Yeah.
You can use a double derivative to find the direction.
Double derivative. So I'm going to take that. It's a formula. I don't know. Wait, formula off the top of my head.
I was ready to punch you in the face.
So you just a straight up formula.
I'm always on the edge.
All right, you basically use the formula. Alternatively, dx dt is 3t squared minus 3. dy dt is equal to 2t. dx dt over dy dt gives you dx dy. Oh, sorry, I want dy dx. All the way around. But so you want derivatives. So I took the derivative with respect to t of both functions, and if I do, I'll write it bigger over here. Everyone's okay with that? So that'll give you your slopes, what's going on, you can find your critical points. And move on from there. And then again, you can do the same. I mean, once you get this, you can take the second derivatives the same way. It'll be, you know, d squared y dt squared. Same deal. Does that make sense to everyone?
Does it not work if we just derive dy or dy dx?
Oh yeah, that's fine. You can do that. The one guy there back there said you can find the second derivative, which is fine. So if you get a concavity, which isn't a horrible thing to have. It'll make your graph look nicer. That's what you did in your class. I would take it. It's not particularly challenging to take a second derivative. Like this one's just going to be 2. That one's going to be 4t. So I would say just take them, and because it's not going to take any time. It gives you the concavity. You can make your graph prettier. And really, it's all we want. Okay. What do the derivatives come out to? 2 over 3t squared minus 3. And then we have to plug in values to figure out what's going on. I would use 1, 0, things like that. So this would tell you, again, this just tells you like the concavity. I don't actually know what the graph does. I assume it does something like this. I assume it's something not hard. I don't really know. What did you actually do it? I haven't actually solved this problem.
I did get to do that. I did not forget to do this.
I could keep going with this graph, but
You gotta drop directions too, right?
yeah, oh yeah. So this is t equals 0. You don't want to label the important points. T equals √3. And you have to give it a direction. That's important for these because that is what these are modeling. So just draw little arrows on your graph. I decided that that's what I won't like to do.
How did you know it like further before this? Like, how did you know go over the point and then further?
I guess. I don't actually know. But to figure this out, you would find second derivative for the concavity. Oh, that second derivative would tell you that. Second derivative would keep telling you that it's concave down. I would use the first derivative, which would tell me the max. You can find the max and mins. So that's sort of it's going to be exactly the same as you ordinarily would graph this function. You can find the max, find the min, find the concavity, and then you sort of figure out what's going on. Max of t equals 1. Should be. I'll take your word for it. Yes, that works. And the min is, yeah, so this is probably t equals 1. I'm pretty sure that's what it does. Does anyone want me to go through this more in depth? This is like, is anyone confused by this basically? I sort of just give you an overview without solving the whole problem.
How would they like give you marks for this? Like, how would you decide marks?
They'll want to see, they'll probably want to see your intercepts. They'll want to see your derivatives. And then based on how beautiful your graph looks. That's just like, that's how they do it. The arrows counts to how beautiful your graph looks. The arrows make it more beautiful. But yeah, so that's what it works with. And you'll probably, my guess is you'd have two of these to show up like this. And it might actually very well be examples you saw in class. I'm pretty sure it might work. Like almost right in class, almost identical, and change the coefficient or something, but otherwise it would be quite similar to things you've already seen.
Wait, I have a question.
Yes.
If the first derivative is undefined, Would that mean a max and min as well, or does that?
Yes. It's the same. Like it's exactly the same as when you were graphing them before. So an undefined is a critical point still.
Yep.
So that could still be a max or min. Just because the derivative of the undefined, like, so this derivative is undefined at t equals 1, right? But these are still defined. These exist. It just means that it's critical. So it's the same as it always was. You just have to use two equations to figure out what the actual point is. Any other questions before I move on? No? Okay. Cool. Conic, go back to, just go all the way to the bottom. We're going to go back to Taylor series. Conics, you guys didn't cover these?
We did lips.
No.
You did lips.
I heard you said you didn't do conics, right?
No, 137.
Conics was in your syllabus. Oh, okay.
My teacher taught us to know reading. We have the headphones. We have the headphones, bro.
You know, but she also said it's going to be exactly what
I don't remember.
well, headphones.
Okay, anyway, so conics, not a big deal. Those are fun though. Now we'll look at Taylor series. These are super easy, so we're just gonna skip over. So Taylor series will be on your exam. They're hard. I can only tell you so much about them. I would recommend, because I don't have all the time in the world. But, so just a quick plug for GradeUp here. Our other tutors, if you book an hour, they can tell you all about Taylor series for the whole hour. Probably. If you ask them to, they will. They might not tell you the right things, but they'll tell you about them. They'll tell you the right things. I'm just kidding, yeah. They know their stuff, they're also, they don't got those. The exams in a week? Oh no, it's not too late. You gotta book 24 hours in advance. Anyway, okay.
I'll give you some more
Yeah,
details about that.
I can see it. Okay, Taylor series. Memorize the formulas. I think I have some tips. There are certain ones that you should memorize. Because your goal in Taylor series, you never want to use the definition of a Taylor series. The definition of a Taylor series is a nightmare. This CN is not fun. If you're sitting on the exam being like, damn, I don't know how to do this at all. And you start when I came to this exam, I didn't know how to do that. I didn't know how to do Taylor series, so I got that question wrong. And I tried to do it this way. And it's very complicated and it takes way too long. So, what you should do, memorize these. I took them exactly from your, oh no, I got this from a handout that I got in Math 138. You also get a handout? No? It's just in the textbook? Okay, I was getting a handout. I'm just a lucky guy. I know, there's a whole handout to cover. This is just one piece I took off the handout. Anyway, memorize these. Your goal for Taylor series, and I'm going to say with 99% certainty, anything they give you regarding Taylor series on your exam is going to be able to be manipulated into one of these forms. Or, I think these are the big ones. You don't need to really know the other ones. So your goal, you'll see the Taylor series. Hopefully it's Maclaurin, because those are easier because it's around 0. But your goal is going to be to manipulate it to make it look like one of these. Once you do that, you've hopefully memorized this and you know if you get it to look like this, 1 plus x to the k. If you get it to look like this, it's cosine x. So, and it also might ask you the other way to write the Taylor expansion for sine x. It might tell you of some function, in which case you want to make it look like one of these to make your life easier. Yes?
So if we're asked for the radius of convergence of a Maclaurin series that looks like this, but is times let's say x or x squared or something, can we just say that the radius of convergence is the same thing as the original Maclaurin series because multiplying it by whatever doesn't change that radius of convergence?
Yeah. Yeah. Because they won't give you something that you actually, hope, they won't give you something that you need to evaluate the formula. Like you need to actually go through the step, like the formula of a Taylor series. Yeah, because it takes forever.
It's like the assignments, I think you have to do the derivatives, and then figure out what the value is at each derivative, and then find a general formula.
That's too bad. So this guy, so the guy in front here pointed out that in your assignments you had to evaluate at certain values and figure out what the formula is. Okay, I guess they might give you that on the exam then. But if but it wouldn't be any more complicated than what you saw on your assignments. I don't know how hard your assignment was. I guess it got easy based on the struggles. But if they tell you to find the Taylor series expansion, I'm actually guessing they wouldn't make you do it out, find a whole bunch of derivatives. Like I said on my exam, that's how I started going through it, and I had a fairly complicated function, and it took up a ton of space, and I got the wrong answer.
Could you have done it like the easier way?
Yeah, you could have done. I could have done it this way. This is the key to practice. You're gonna want I recommend just do a handful of examples of them and look through and try to figure out how to manipulate them properly.
What do you mean by manipulating?
You're just gonna yeah, you want to, what your goal is going to be, you'll have, they'll give you some mess of a function, and you just want to sort of move things around to get it to be, this form. Like maybe, you can't integrate and differentiate something.
Yeah.
You might be able to do that. That might take a while. So the people up here, just so everyone knows, they're asking how you would sort of go about manipulating it. My recommendation is to practice these. You just sort of you just need to go through practice problems of it. I can only tell you so much about them. They are going to be on your exam, which is a shame. Hopefully it's a McLaurin series. Mine, on my exam it was. I believe I only had one, maybe two Taylor series on there. Yeah.
Sorry, so when it's a Taylor series, you need to use the actual formula, right? These are only for McLaurin series?
No.
No?
Taylor series, that's my memorized with mine.
Not on the book, it says the common McLaurin series.
So McLaurin series is a Taylor series.
Right.
It's just centered at 0.
Right.
So then would be x is changed, x minus
A. Yeah.
Oh, so it's the only difference that basically you're plugging in whatever manipulations happen on x into. Yeah.
So these are all McLaurin series specifically, just because these are all centered on 0, but it's not x minus some number. Yeah.
So if let's say for sine x, would we start usually with the sigma stuff and then try to get it into function form, or the other way around?
So what do you mean? On the exam, what are you looking at? You sit down, this is the problem. What are you looking at here?
A whole bunch of junk on the right.
You're looking at this or this.
Right. Okay.
My guess is you'll be looking at this, and it'll tell you to simplify.
And then let's say there was a 2 as a coefficient for the x, then would you just say 2x?
Yep.
Yeah.
It would just be sine 2x.
And would you consider that to be a Taylor series as opposed to a McLaurin series?
Well, I guess I would consider that to be a McLaurin series.
Yeah. Okay. Only if there's an addition or.
Only Taylor series and McLaurin series only differ in their what is it called? The point of center. Yeah, center point. That's the only place they differ. Otherwise, these are all Taylor series centered at 0, which happen to be McLaurin series. This is my series now. Otherwise, they are exactly the same. So if this was x minus 4, this would be a Taylor series, not McLaurin series.
And then it would just be 1 plus x visible to the x.
Yeah.
Right. Okay. It doesn't change.
It doesn't change too much. That's why you gotta memorize it, right? And do practice. Oh, what?
You won't delete it?
Yeah.
No, I don't trust this.
It's just gonna keep changing. I do recommend doing practice. Yes. Oh, just stretching. Okay. I'm gonna keep answering your questions because yes.
Well, I can't.
Yes. If it doesn't start, like if you don't have 0 to infinity, these are all 0 to infinity. If it's like 1 to infinity, you have to change it. Because if this was a 1, these would not be equal anymore. You would just subtract off the term. Yeah, you would just change it and you would make this a 0 and subtract off whatever that first term was. Okay, this question is a question that I've been asked to do. The question actually is, use a Maclaurin series in table 1. Here's table 1. To obtain the Maclaurin series for the given function. Okay. So, I have to go through the solution. All right. So we want this to look like one of those. So this one so our goal, we want this to be in the form of 1 plus something squared. That's how we're going to start this one. So 1 plus x squared over 4. Right? Everyone's happy with that? Yes. Oh, yeah, I don't know. Fine. Yeah. Okay. So now we have that. So I'm just going to write this a little different. 2 over 1 plus x over 2 squared. Everyone's happy with that? Yeah, just I might be able to use one of these.
Number 5.
Well, not number 5, I don't have to choose. I have a bracket, not to choose. This is choose. This is K choose N. You have enough stacks yet. Combination.
Wait, wasn't it number 5? Can't you just use K?
Yeah, I'll just try to use the left side, the right side. Left side.
Yeah.
How is it going? What? Sorry?
How did it jump from x squared over 4?
Oh, sorry, I made this. Sorry, it's x over 2 squared. All squared. I know you can't use number 5, but you're just, yeah, you all right. So this, that is number 5. What is that? 1 plus x. Okay, yeah. So 1 plus x. Okay. Right? Well, so now we're just gonna plug in that sum, which is K choose N times x to the n. Oh yes.
Wait, is that the end?
No.
This is a question again. They're asking you to get one of those, right?
Yeah, well, we're using that to solve this.
So when you say like find a Taylor series, are you getting the stuff on the left or right? The middle.
It depends. The question will ask for different things. Because you might start, you can start at any different point. Like we started, in this case we started with that example and we worked until we got to 5.
Wait, so what do we have?
So what do you have now? What is that?
So that is the, that's the Taylor series. Like that's the generalized form of the Taylor series. Not the Taylor series expansion. The expansion would be the far right thing.
Yeah, all you gotta do is like something different. You can bring that.
Sure, if you want to. Yeah, you could do that if you want. That makes you happy. Okay. You have to keep going though. You're not done. This is where we use the expansion.
So the question is asking for your expansion.
The question was asking for more time. The R is top. So this is the expansion. Just using that. Which one? They won't tell you. I'm gonna write 2. Well, I always, start with 1. And then I'll write 2 more. Yeah. You probably want to, don't just do 1 term. Because if I did 1 plus this plus ... it shows I don't know anything. I just happen to get the first term. I don't actually have any idea what I'm talking about. So, fairly safe to do this. Sorry, can you not read that? Where do I lose you?
After the negative 1/2 times
No, you don't need it, but
So you don't know this term? Negative 1/2 times negative 3/2 over 2 factorial times x squared over 4 squared. It's just this. It's just this expansion. I'm only running up the 2 terms today, but plus . So are we all still on board with how this is going? Yes. That's good to hear. We'll move it over here. Set it over. Can you see if I write it here? If I scribble on down here?
Yeah.
Okay. So this is, we're solving for us. We're just doing some work in between here. What? Hold on, give me a second. Let me just remember it. Don't worry, I'll tell you what's going on. So are we all upset? This step here? Okay. So for starters, I multiplied this out. I brought this in like you wanted to earlier. So that's where x. I might have been wrong, but yes, this is just x. Right. So I multiplied this out. Brought it here. Then this again is just x. So then this is the rest of this here. All right, for now. So it's this times all this. So just distributing that x over 2. So then, what did I do? Negative 1. In fact, I just took out the negative 1. There's a negative 1 term because it's negative 1/2. So it's negative 1 to the n, because I've just factored out that you just have a whole bunch of negative 1s. Then I have those. Okay? Because as I keep going, this is going to be just by the Taylor series stuff. This is, n minus 1, n minus 2. So you're going to end up with negative 1 to the n. Okay? Again, this 2 to the n, because this one, it's going to be 2 times 2 for the second term. The next one's going to be 2 times 2 times 2. So 2 to the n. Is everyone okay with that so far? Yeah. Same deal with the 4. We have 1, and we square it, and we cube it. Keep going. So that's where that 4 came from. Everyone's okay? Again, 2 factorial. Next term's going to be 3 factorial, and factorial. I've taken this chunk and written it as an infinite sum, starting at 1. Does everyone see where all those terms came from? Yes.
I have a question about how you get the 2n minus 1 term. So you go from 1, 3, 5, right?
1, 3, 5, 2n minus 1. See how I'm doing all the odd terms?
Yeah.
1, 3, next will be 5. Because you're starting at the negative, the 1/2, every time I subtract, like if I subtract the second time, I get negative 3 halves, not negative 2. So it ends up as being 2n minus 1 instead of 2n. Does that make sense, sort of?
Yeah. There's a formula you can use. It's k minus n plus 1. So you plug in your k, and then you just solve. K.
Was there another question over there somewhere?
And that'll give you like your
No. Okay. So, yes.
I'm just wondering, why do you have 2x over 2s at the beginning? And instead of writing it as your sum with those up front, why don't you just multiply the x in, and then it just becomes x to 2n plus 1? And if you'd done that, would it still be right?
At this point, yes, it would still be right.
Yeah.
You could have done that.
But you wouldn't have the x's in front.
You wouldn't have the x's in front.
But
well,
I left a 1/2 in front. Is that?
The 1/2 can go anywhere you want. It's just a constant term. Why do I have 2? Because I wanted to write it based on an infinite sum.
Why?
But that's what you change it.
Oh yeah, the bound changes. I said 1 instead of 0.
Okay, fair enough.
Why did I want that as an infinite sum?
Yeah, like, could you have just gone small? Like, not a 0? Or would that be going back to us?
It also works sometimes because the first 2 or 3 terms don't follow the same pattern.
Oh, okay.
Like, the reason why you need to take it out, I think, is because the first few terms don't follow the same pattern as the rest.
Is that the case here?
Yeah.
Like, why did you change it?
If I started at 0,
Yeah.
this would have been 0. Or that would have been negative.
Oh, it would be negative 1.
I would have been upset about that. I would have had a bunch of zeros all over the place. 0 factorial, I can't solve. Oh, sorry, 0 factorial is the one I could have solved. But I still would have had a negative number here.
Oh, so it just doesn't look good.
Yeah, the first term just gets run, so that's why I took it out.
Is that the case every time? Or do I have to go to
They'll probably be different terms here. It's not the end of the world if you just do this every time. You're welcome to factor out things. Maybe you have to bring them in later again, but you can do that. It's not the end of the world. It's just one extra step they end up doing.
You just added like a 2% that's not safe
Yeah, that's where did it compensate? I have to plug that in.
Okay, anyway,
Yeah, check it.
No, but when do you do that? Like, that's when it's
Let's do part of this. So this is using that right? This is
Hey guys, can you just keep the noise level down so that everyone can hear?
So what I want to do now, it's only for R. I haven't found my R yet. Oh, I could have stopped. Yeah, I probably would have stopped here.
really? What?
Well, unless they ask me to expansion.
Unless I want the expansion, in which case I would have done this.
What would you consider this? Is that the same thing as
This is the expansion of this.
but like this? Like,
This is a variation of this. This is, I've simplified, taking it from an infinite sum, I've expanded it. Now changing it to a different infinite sum. Because why not?
So what, how should we write it?
What's the ratio test?
Well, we know R, right? Just based on the fact that it's a binomial series, right? And then there's different traits. Because it's negative 1/2.
Well,
Between
I'm going to spoil it for you, R is not 1. Because this is not the same as that. This is x over 2 squared, 1/2, negative 1/2. So I don't know that that's 1. No, we're still trying to find it. I'm just answering questions. Okay. No. Because they told me. They want you to use the Taylor Maclaurin series. So that's what we do. Okay. Just that. Okay. So now I'm going to do what you want me to do. Bring this inside. See how I got that? Which one? Sorry, this is 3. I'm just having trouble writing that level. Sorry, what was that? Oh, yes. I just forgot to write it. Yeah, it's still there. Okay. This is where I think it's going to be. X squared over 4 plus 4.
X squared over 4.
Yeah, sorry, that's a 4.
We got it from there.
Where did I get it?
From x over 2 squared, the radius has to be less than equal to 1.
Yes. That is one. Thank you.
With absolute benefit.
It's always positive x squared. So, you want to explain? You want to tell her? Choose. Go ahead.
We took it from the over number 5, the radius equal to 1. So let the x term be less than or equal to 1 because that's what radius means. And you solve x.
You sound good.
Your x term in this case is x over 2 squared, right? Like the top line.
Yeah.
So you're gonna
So that's your x, and your x has to be less than 1, so you just...
X has to be less than 1, because that's the radius. So that's going to come with
Wait, so for the EX, sine x equals cosec formulas, will the radius always be negative minus 1?
Yeah, those radiuses are always infinite. Okay. Okay, I'm going to start through those last few steps there. Yes, sorry. Oh, sorry, yeah, I got it. N factorial, 2, 3 to the 3n plus 1.
Oh, yeah.
Did everyone see where that came from?
Yeah,
that's right. Where? Yeah, the question wanted you to do all this crap.
Wait, so when do you know when to like make it like expand it and then put it back? When do you know when to do that?
I don't know what the question asked you to do.
Yeah, like what would the question ask?
What would it ask specifically? It would say, use one of those to write this as a Taylor series, or sorry, as a McLaurin series. It does not Taylor. Set it at 0, and then it'll tell you to find the radius convergence. It'll tell you certain things to write. It'll say, write it in that, use that to find the expansion, simplify, like things like that. It'll tell you. Yes.
So the
sorry, you guys can have
Do you have to do this in Calc 3?
Nope.
So like
Excellent.
Calc 3, do you base anything off Calc 2 or just do something?
What is it?
Yeah.
What's Calc 3?
Calc 4 is
Calc 4 I have not taken yet.
Calc 4 is awesome.
Calc 4 is if you want to take it.
I'm going to be doing.
I'll come back to that.
Okay.
I'm just wondering, so would this be referred to as something like there in representation? That's it, or this?
Yeah.
Something like that. So once you expand it and then turn it into this. Okay.
This bottom that's right here. That's the Taylor, sorry, the Taylor representation of that. That one also is. These are all equal. These are all the same. Yeah. Yes.
So for the when you calculate the radius of the convergence for that power series, you have to show your stats by doing the equation consistently. Or you actually know that like the radius is 1 for a binomial series, you know that the x2 is x squared.
You just know.
So it's not.
You don't need to show. You don't need to be like, so I used the ratio test.
Right.
You just say, you could just write like, because it's binomial series, I know this, and then just do these steps.
Right.
You should be fine. Any other questions on Taylor series before I tell you what Calc 3 is all about? Nope, everyone's happy with Taylor series. Practice them. You just have to like go through examples. If you want to book additional sessions with people, they hopefully can help you. I think they can.
First off, thanks so much for coming. I hope, and thank you to Garrett. I appreciate that you guys gave me a round of applause. I hope you guys learned something valuable. And as Garrett mentioned, we do have additional tutors on hand that do teach Math 138 and various other UW and WLU courses. So if you are interested, go on to the website www.gradeup.ca. It's very easy to book a tutor. We have several packages if you're looking for sort of like one session just to like get you geared up for the exam. It's $30 per hour. In addition to that, we also have a 5-pack, which is basically a session of 5 separate hours. That is $26 per hour. And finally, a 10-pack, which is $25 per hour. And all of those, like GradeUp is, we basically stand for, we try to improve people's learning styles and learning habits consistently. So that's why we have those packages. to accommodate. We don't normally do group sessions. This is actually our first one, and hopefully in the future we'll be able to help you out more for midterm and finals review sessions. Seeing the turnout was pretty good. But in addition to that, you can always go on the website and look at the various courses we have. And any other questions related to GradeUp itself. Oh, and all our tutors have they require a mark of 85 or higher to be tutoring a course, so they are experts in what they're doing. Yeah, I know. So you know, you can expect the best. We hire very carefully based off that. And if you are interested in being a tutor, same goes for that. Just let us know. Send an email to gradeup1@gmail.com. And you can also find us on Facebook and Twitter. It's a great, well-paying job, and it's very flexible. But yeah, any other questions related to it?
Yeah.
That's about it. Yes.
Okay.
That is my email address.
Yeah, that's Garrett's email address right there.
Shoot me an email if you have questions for.
Can you answer like how much GradeUp makes a year?
Probably a little confidential. we'll leave that to the side. But yeah, to be clear, we are a private business.
Not publicly traded.
No, not public. We haven't gone through an IPO yet. Pardon?
You guys donate like SOS?
No, we're for profit. We feel the best. We feel the best tutors. We feel you can get the best tutoring experience by hiring tutors for profit. So yeah, no, we're not a social venture. We're also not associated with any school specifically, in that we are a private business on our own. However, we do have partnerships with Wilfrid Laurier University, UW now, and various other places such as athletics and various things like that. But yeah, so you know, this is a business that we are trying to build. But at the same time, like, we understand the importance of sort of giving back to the community, and that's why we hire tutors and people. We have a sense of community spirit, and you know, that's what we're all about. Great. Cool. Anything else? If anything, I'm sure you can talk to Tyler. He can maybe give you more information on that. I'm not sure about that. But anyways, I think you have a couple more questions on that stuff. So Garrett will help you out with that. Other than that, thank you very much.